Okay, can you see my screen now?
Yes, sir.
Perfect. So let's see this part now. So question is saying that what is the acceleration of the block and the trolley system shown in the figure 5.12a, and the coefficient of the kinetic friction between the trolley and the surface is 0.04, and what is the tension in the string, and neglect the mass of the string. Okay, so we read this part that whenever there is a rope, okay, and the rope will having the force which is called the tension. Clear? Now when you draw the free body diagram for this part now, because we remember that we discussed that part that the rope will having the tension in the string. So tension is nothing but the force. So when we only consider this body, right, so this body is moving, isn't it, because it has a kinetic friction. So if you remember that he talked about the kinetic friction. Kinetic friction comes in the picture only when the body is in the motion, right? So consistent friction is there. That is what is given by the consistent friction. Fine. Now, so what are the force acting on it now? There is this rope is pulling this weight, isn't it? So for the time being, just forget about the tension. Just in the place of tension, just put it the force. Is it okay? If I replace this body, this as a F now, is it fine? If I, for time being, I just replace the F, so that means there is a force which is acting in the, which is making the body move in the right direction. Fine. And there is a kinetic friction which is acting in the left direction. Is it okay now? Then I can say that. Fine. Now when I take the free body diagram for this, doesn't look like this part. This is the weight of the body. And this, since why I am not talking about the weight in the downward direction right now? Because it is in the motion. It is dynamically balanced now. Clear? So there is a force acting on this part. So we are just representing what are the two forces which is acting, which makes the body in the motion right now. Weight acting downward is not creating the motion, isn't it?
Yes.
So motion, which creates a motion, is what we are, because this is a kinetic friction. That means the body is already in the motion. So we need to find out dynamic equilibrium right now there. Which force? Doesn't matter which direction of the force is. One is the kinetic friction on the left hand side, and this is the right hand side, isn't it? So net friction is what? Net friction is basically not net friction, net force basically. Net force. This, if I just represent this as the force here, okay. Now what happens now? The resultant, if the resultant direction is in this direction, right? If it moves in this direction, the resultant force, net force will be F minus Fs, F minus Fk. Correct?
So it's moving towards right.
Yeah, moving towards right. Correct.
Okay.
Correct, no? Okay, next part. This part is clear? Any questions, any doubts in this part?
No doubt, sir.
Perfect. Now let's consider this part. Now we have already learned that whenever there is a rope is there, so same force will be acting everywhere in the rope. So if the tension, but direction can be different. Direction can be different. So it doesn't mean the force is acting in this direction going in. When it comes here, it is also acting in this direction. No, not really like this. So whichever the body you are considering, it will be always opposite to that. The direction will be the force direction for the rope will be there. So since the force is replaced with the tension, so basically now we'll consider this part now. Now we'll consider this part. Now what is happening in this case? Now if I try to draw the free body diagram for this part, so there is a force which is acting 30 Newton on the downward direction, right? How 30 Newton? Because 3 kg is their body. 3 kg is what will happen now?
And the gravity.
Gravity. So basically 30 Newton is acting in downward direction, right? So the gravity is in down. And the rope is exerting the force on the upward direction. Right? That is the tension. T is equal to nothing but F only. So if I represent like this, it goes like this, isn't it? So only two forces acting in there. One is the downward direction, other is upward direction. right? Clear?
Yes, sir.
Perfect. So that's what is being done now here. Now question is, we need to find the tension in the string now. So it is already in the motion now. Coefficient of friction is there to you. Coefficient of kinetic friction is already given. That you can easily calculate using the formula F is equal to mu n. Right? F is in mu n should be creating the mass into acceleration. That force should be equal to the whatever the net force here. First you equate it. Now T basically, now clear what is the tension in the string his question is asking you. So what are the three equations you get now? T is equal to 30 Newton here. Correct? And here this part is what? F will be net force is given as F minus Fk will be equal to mass into acceleration.
So, but like the force on T, will it be the same throughout the rope or just for
throughout the rope?
Oh, so it'll be 30 Newton throughout.
Throughout. Force on the rope will be always the same.
Okay.
Force on the rope will be always the same part. But what we need to derive is, because see, this is the free body diagram we have done. Huh? Now if you want to see that part, let's see, look, question is this part. See, basically we are talking about the acceleration, isn't it? Because this body is in the kinetic friction, that means this is the motion, right? So that means this is going downward, this is, going this, in the horizontal direction, right? Correct? So basically, if it is going that down, horizontal direction, so that means this part, this equation is important, okay? 30 minus T is equal to 3a. Why did we get 30 minus 3 is equal to 3a? Let's understand this part, okay? Now, if this body is moving this direction, okay, so we'll calculate that, net force is going in the downward direction, right? So net force is basically, net force is making the body 3 kg move in the downward direction. So it will have the acceleration now.
So like if the body is moving down, then so you will subtract the T, right?
Yes, because the T is going in opposite direction. So net
and the force acting down is more than T, right?
Yeah, correct.
Because exactly. That's the reason it's going down.
Absolutely correct. So net force will be net force in the downward direction, right? Direction is equal to 30 minus T, right? So net force is making the body move in the downward direction. So 30 minus T should be equal to that. If it is moving, that means it has acceleration. Because the force is acting on this, net force is creating some acceleration. That should be equal to mass into acceleration, correct? So here 30 minus T. What is the mass here? 3 kg.
3.
Acceleration we don't know, we can find out acceleration. Similarly here also. Net force is how much? T is anyway this part. So net force here is T minus Fk, correct? T minus Fk in which direction? In this direction? Correct?
Yes, sir.
Now T minus Fk is same direction, so that means the same force is there. So T minus Fk should be equal to mass into acceleration.
So 20a.
Correct. Is equal to 20a. Fine. So now you got two equations now. Can you see that? Fk value you know. Coefficient of friction is given to you. Tension you don't know. 30 minus T is 2a. So basically two equations, two unknown variables. So you can use the simultaneous equation to solve it and get the answer, isn't it? See, Fk is what? Mu into n. Mu is they have given to you 0.04 into 20 into 10. 200, so basically we'll go 8 Newton. Correct, no?
Yes, sir.
So now mu Fk value you know. So this is basically Ft minus Fk. So basically you get is T minus 8 is equal to 20A. Correct? And 30 minus T is equal to 3A. So you got two equations. Two equations.
We can substitute one of them.
Yeah, you can do any method here. This is the first equation. And this you get it second equation, right?
So we can find acceleration and the tension.
Yeah, both you can find. No? Yeah.
Okay, sir.
Understood or not?
Yes, sir. Understood.
Perfect. Now do that, you'll get it.